Greetings to all the students. I hope you are well and studying as well. So, welcome to the video lecture again. In the previous lecture, I have explained you the examples till example number 8. So, today we'll move on to our exercise, that is exercise 1.2. So, see, we'll look for this question. Question number 1. Express each number as a product of its prime factors. Right. So, I'll take this first one. So, your first one is 140, right? So you know how to solve this 140. I have already shared two methods to calculate prime factors, right? So the easiest method is like prime factorization method. So first of all, you'll take 2. So here you are getting 70. Then again 2, then 35. Then you are getting again 5, then 7, right? So you got 40 equals to 2 multiplied by 2 multiplied by 5 multiplied by 7, right? So this is 2 to power 2, 5 and then 7, right? So this is how you will be explaining this number, right? Okay, one thing that you should keep in mind while finding out this prime factors, how you'll start from the smallest prime number, right? So the smallest prime number is 2. Then if it is not divisible by 2, then you will move on to the next prime number, that is 3, then 5, then 7, then that 11, then 13, then not 14, 15, 16, 17, 19, 23 and so on, right? And I want you all to learn this sequence, right? You should know at least this sequence from 2 to 23, at least this sequence. Rest all that is after that will take it afterwards, but till 23 you should know, right? So let us take another example. This is your fourth one, 505, right? So 5005. How can we write this? 5005. See, it is very much clear that you cannot divide this by 2, right? So we'll try to divide this by 3 because the next prime number is 3. But I guess it is neither divisible by 2 nor by 3. So no. The next one is 5, right? So I guess it will go. So 1, 0, 0, 1, right? So is it divisible by 5 now? No, this is not. So the next prime number is 7. So can you divide it by 7? Yeah, you will be getting 143. Now, so 143 you got. Next, can you divide it by 7 now? No, you can't. So the next prime number is 11. So we'll take 11. So this will give us 1 and 3. And 13 is your prime number, right? So clearly you can get your 5005 will be equals to 5 multiplied by 7 multiplied by 11 multiplied by 13. Understood? So this is how you will be doing rest of the parts. I did first and fourth for you. Now you will be doing second, third and fifth at your own, right? So this was for the first question. Now we'll move on to our next question. Question number 2. Question number 2 says find the HCF and LCM of the following pairs of integers and verify that LCM multiplied by HCF equals to the product of two numbers. See, in our previous lecture I told you about this rule that if we get the product of the two numbers that has been provided to us, that will be equal to the LCM and HCF of those numbers, right? So if I take this first one, this is 26, right? So how can you write 26? See, it is very much clear that you can write 2 multiplied by 13, right? 2 and 13 both are prime. So it will be like this only. Next is 91. 91 can be written as 7 multiplied by 13, right? Okay, so this is 7 multiplied by 13. Now next, find the LCM and HCF of the following pairs. So finding LCM and HCF. Let us find out HCF first, your highest common factor. So highest common factor here, you can find out that only 13 is the factor that is common, right? Only 13 is common. So this can be written as HCF is 13. Now LCM. LCM will be 2 multiplied by 7 and the common one is 13, right? So 2 multiplied by 7 multiplied by 13, that will give you 182. Now you got your points. 26 is your first number, 91 is your second number, 13 is your HCF, and 182 is your LCM, right? So what we have to prove? We have to prove that the product of these numbers will be equal to LCM multiplied by HCF, right? So 26 multiplied by 91 will be equals to 182 multiplied by 13. So you will be calculating the values by yourself, and then you will be getting LHS equals RHS. Hence you will be proving this formula that you have derived, that you have actually calculated in your previous lecture, right? And similarly you can find out for this second and the third one. So let us do this. Second one says 336 and 54, right? 336 and 54. So 336. See, by using that prime factorization, you will be calculating the values. If you are unable to do this factor thing at your own, just calculate this in rough and then you will be getting the prime factors, right? So 336 will be equals to 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 3 and 7, right? So this is 336 and you can write it as 2 to power how many times? This is 4. So 2 to power 4 multiplied by 3 and multiplied by 7. And your second number was 54. 54 can be written as 2 multiplied by 3 multiplied by 3 multiplied by 3, right? And you can write this as 2 multiplied by 3 to power 3, right? So this is the prime factorization. Now you will be finding out the HCF, highest common factor. So highest common factor among this is, I guess only 2 and 3 we have. So 2 and 3. And what is the lowest power for 2? So lowest power of 2 is 1 and the lowest power of 3 is also 1. So your HCF will be nothing but 2 multiplied by 3, that is 6, right? Okay, next is LCM. LCM will be multiplying all the factors 2, 3 and 7. And the highest power for 2 is 4, highest power for 3 is 3 and highest power of 7 is 1, right? So after calculating these values, you will be getting the LCM. So your LCM is 3024, right? So 3024 is your LCM. And similarly, to prove this, LCM multiplied by HCF is equals to the product of two numbers. You will be doing this multiplication at your own. HCF multiplied by LCM is equals to product of two numbers. Product of two numbers, right? So your HCF was 6, then 3024 and 336 multiplied by 54. Again you will be getting this value, some value here, and your LHS equals to RHS, and hence you have proved this. Okay, so this was for question number 2. So you will be doing question number 2 at your own. Question number 2, part 2 at your own, right? Okay, now we'll quickly move on to question number 3. So what is question number 3? Question number 3 is again find the LCM and HCF of the following integers by applying prime factorization, right? And you can see that this question is a bit different from the second one. How? Because you cannot use the property which has been mentioned in question number 2, because you are having three numbers here. So for three numbers we are not supposed to use this formula, right? So how will be calculating? You will be using prime factorization method only. Okay, now we'll move on to our question. This is first one is 12, 15 and 21. 12, 15 and 21, this one. So 12 can be written as 2 multiplied by 2 multiplied by 3, or 2 to power 2 multiplied by 3, right? Then 15 can be written as 3 multiplied by 5, and third one is 21. So 21 can be written as 3 multiplied by 7, right? Now you have to calculate LCM and HCF. So your HCF is highest common factor. So what is your highest common factor among these? You are getting 3. 3 is common in all. And what is the lowest power? Lowest power is 1. So your HCF will be 3, right? And for LCM, we'll be writing all the prime factors we have. 2 multiplied by 3 multiplied by 5 multiplied by 7. Now we'll look for the highest powers of these prime factors. So look at this 2. Okay, so 2 is having 2 as its highest power. For 3 it is 1, for 5 it is 1 as well, and for 7 also it is 1, right? So clearly your LCM will be 2. This is 4 multiplied by 3 multiplied by 5 multiplied by 7, and this will give you 420. So your LCM is 420 and your HCF is 3, right? So this is how you will be calculating this question number 3, because you have been provided three numbers, so you cannot apply the previous formula that you got, right? Product of two numbers, that is equals to LCM and multiplication of LCM and HCF, right? So this was for question number 3. And one thing that you should look out for this question number 3 part 2, that see, this is 17, 23 and 29. Okay, so 17, 23 and 29, these three are already prime numbers, right? So if these three are already prime numbers, you cannot factorize them further. So that cannot be factorized. So very easily you can write the HCF as 1, right? Why? Because you know that if it is a prime number, it will be having factor 1 and the number itself. 1 and the number itself. So for 17 it will be 1 and 17, for 23 1 and 23, and for 29 1 and 29, right? Usually we do not write 1 and the number itself for other composite numbers because that is very much clear. And for if we multiply 1 with any number, we'll be getting the same number, so we don't write 1 every time, right? But here in this question you are getting all the three numbers as prime numbers, so you want to be factorizing it further. So clearly you will be writing 1 multiplied by 17, 1 multiplied by 23, 1 multiplied by 29, and you can get your HCF as 1 because 1 is the common one from these three, right? And for LCM again you will be doing this multiplication for three numbers. So 17 multiplied by 23 multiplied by 29, and it is understood that if you multiply by 1 you will be getting the same that you get by multiplying these three, right? So this will give you your LCM and your HCF will be 1 for question number 3 part 2, right? Okay, so this was for question number 3 part 2, and you will be doing question number part number 3 at your own. Okay, so this was for question number 3. Okay, now we'll move on to our next question. That is question number 4. Okay. Question number 4 is, given that HCF of 306 and 657 is 9, find the LCM of 306 and 657. So this is very much clear that you will be using your previous formula, the only formula that you have learned so far. So yeah, for HCF of 306, you will be writing the prime factors. Oh, okay, wait. So you are having 306 and you are having 657, right? So these two are the numbers, and your HCF is 9, right? So you know that the product of the two numbers, because your product of numbers is equals to LCM multiplied by HCF. So clearly you will be getting your LCM is equals to your product of numbers. Product of numbers are 306 multiplied by 657 divided by 9, right? Understood? So you will be using your previous formula and you will be getting the LCM. So your LCM will be, keep on simplifying this, and you will be getting 306 multiplied by 73. This will give you 22,338. So this is your LCM, right? So this was your question number 4. Okay class, I am explaining this video lecture. I am sharing some another lectures of other person available on YouTube as well. But if you are facing problems, still if you are facing problem, you can contact me anytime, right? Okay, so we'll move on to question number 5 now. Question number 5 is, check whether 6 to power n can end with the digit 0 for any natural number n. Okay, so if you remember, in our previous video, we were doing an example that was for 4 to power n, right? So for 4 to power n, what we did? We factorized 4, right? So factorizing 4, we got 2 to power 2. Can we factorize it further? No, we cannot factorize it further, right? So because for the digit to end with 0, that means for the digit to end with 0, we must have 2 and 5 as factors. But for this case, we were having only 2 but not 5, right? So that was wrong because fundamental fundamental theorem of arithmetic didn't allow us. So for the with the same reason we can find out this 6 to the power n, right? So 6 to the power n, how can you factorize it? You can factorize it like 2 multiplied by 3 to the power n, right? So this will be 2 to the power n and 3 to the power n, right? So because it is not of the form 2 to the power m multiplied by 5 to the power n, that's why it cannot it cannot end with digit 0. End with digit 0, right? 2 to the power m, 5 to the power n. So this is your answer. So this was for your question number 5, right? Now I'll move on to question number 6. Question number 6 is explain why 7 multiplied by 11 multiplied by 13 plus 13 and 7 multiplied by 6 multiplied by 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1 plus 5 are composite numbers. Okay, do I need to remind you again what are composite numbers? I guess not. See, because I have already discussed in almost every video lecture that I have shared till now what are composite numbers and prime numbers, right? So composite numbers are having factors more than 2. So we'll check it for these two numbers that has been provided here. So okay, so what has been provided? 7 multiplied by 11 multiplied by 13 plus 13, right? So you can see that you are having a plus sign here. You are having a plus sign here, right? So if I take 13 common, if I take this 13 common, right? So 13 has been taken common. So you will be getting 7 multiplied by 11 plus 1, right? So plus 1. Okay, now this will be equals to 13 and this is 77 plus 1, right? So 13 multiplied by 78. Okay, now see, whatever value you are getting after multiplying it 13 and 78, you will be getting some number. This is 114, right? Okay, leave that. If you are not calculating this value, still you know that it cannot have factors instead 1 and the number itself, right? So if you are getting 13 and 78 in multiplication, that means these two are the factors of this number, right? So even if you don't write this 1014, even if you don't write that, after this step only you can say that this number is having factors having okay wait having factors more than 2, that is 1, 13, 78 and the number itself, right? And the number itself. So this is very much clear that this is a composite number. This value that has been provided to you is a composite number, right? And the same thing you will be doing for the second one. This is 7 multiplied by 6 and all whatever it is you are having You are having a plus sign in between, right? You are having a plus sign here in between. So again, when you take out this 5 common, you will be multiplying rest of these values, that is 7, 6, 4, 3, 2. You will be multiplying this and then adding 1, and then you will be getting that something is multiplied by 5, right? So again you can write this, that uh, the number which has been provided is having factors more than 2, that is the 1, the number itself 5, and the number that you got after this multiplication and addition in this bracket, right? So this second part you will be doing yourself. So this was for question number 6, right? Okay, now we'll move on to question number 7, which is the last question of this exercise. Okay, there is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same, right? Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the starting point, right? So, okay, now see, one person is taking one person is taking 8 minutes, sorry, 18 minutes, and the other person is taking 12 minutes, right? So they say that they are okay, after how many minutes they will meet again. So if they started at a point, right? Okay, circular path it is. Suppose this person starts from here and okay, let me do this here. Hmm. Okay, this person starts from here and he's completing one round and he's reaching here in 18 minutes, right? Okay, now next person starts from here, right? And after the, because he's taking only 12 minutes, right? In 12 minutes he reaches here. So after 18 minutes he will be reaching somewhere here, right? Somewhere here he will be reaching, right? Okay, so this is quite uneven, right? So if you find the LCM of these numbers, if you find the LCM of these numbers, you can easily get the time value when they both will meet, right? See, this is like, if you go on multiplying, if you go on calculating the multiples, you will get a common value at some point, right? So that will be the time at which they both meet. Okay, let's see. This is 18. So 18, how can you write this? You can write this 2 multiply by 3 multiply by 3, right? And 12 can be written as 2 multiply by 2 multiply by 3, right? So if I calculate the LCM, I'll be getting this 2 and 3. So 2, you can write 2 multiply by 3 to the power 2 and 2 to power 2 multiply by 3, right? So 2, maximum power for 2 is 2 and maximum power for 3 is 2, right? So you'll be getting 4 multiply by 9 and your answer is 36 minutes, right? 36 minutes your answer will be. Now see how this is going to happen. See, suppose, okay, so 12 minutes, the person completed this in 12 minutes. Then again he will be completing it in 24. Then again he will be completing it in 36, right? Similarly for 18, then after one round he will be at 36, right? So this is the common value. This is the least common value that you are getting, right? So this is the time at which they both will meet. So this was for your question number 7 and this was for your exercise 1.2. So this is your task for now. Complete this exercise click a picture of it and send it to me so that I can cross verify how many of you are doing it genuinely, right? So in the next video lecture, I'll be sharing you this theorem. I got a very interesting video, so I'll be sharing that video only. That is very good. So this is theorem 1.4, root 2 is irrational. For this, I'll be sharing a video the next day. This theorem is for understanding purpose only, that won't come in your exams. So you can just take a look at that theorem, but you are concerned with this theorem 1.4 only, right? And the rest of the thing I'll be sharing you in the next video lecture. So complete this exercise 1.2, and this is for today's class. Thank you so much, class, and stay safe, stay at home, and keep studying.